In this video, we're going to be explaining this problem from the 2024 AMC 8. This is problem number 14, and this one has a bit of a diagram accompanying it today, so kind of a geometry problem, but just a general kind of logical explanation here that you could come to. The one-way routes connecting towns A, M, C, X, Y, and Z are shown in the figure below, not drawn to scale. The distances in the kilometers along each route are marked. Traveling along these routes, what is the shortest distance from A to Z in kilometers? So here we have our diagram. So we're trying to get from A all the way to Z to the other end of the diagram, and we need to do it in the least amount, and they have the numbers right here. So one of the fastest ways to solve this problem is to just look at the numbers. Because you've got this huge 25 connecting M and Z. That's going to waste a lot of the already little amount of kilometers that's allowed. So, for example, if you go from A to M, that's already 8. Then you blast on along the 25 from M to Z. That's a huge amount of distance you've already wasted. That's 33 kilometers. So, if you just look at this and see the 25, you should immediately say, oh, that 25 is way too long. There's no way that's going to be the shortest solution. Likewise, if you see the 17 bridging Y and Z, that's also a similar situation because not only is 17 on the longest side, you have to travel through a 5 and a 10 to get there. That's going to be like a 32 again. So, using this 17 is obviously not the optimal solution. So we're looking for the lowest numbers here. That should be your goal, to find the lowest numbers to travel along and avoiding the large 10s or 17s or 14s that we have on here. So that rules out A, M, C, Z, A, X, Y, Z, and all of those longer ones. And right away, you could see that we have a 5 here, we have a 2 here, very short, another 6, another 5, and then just a moderate 10. So right away, what you should be able to do is you should be able to see these small numbers and say, if we go from A to X, that's 5, add only 2 more, go X to M, add only 6 more, go from M to Y, that's already going to be lower amount of kilometers than if you went directly from A to C. If you went from A to C, that would be 22. If you went from A to X to M to Y to Z, that's going to be 7, 12, that's going to be 18 along this path, compared to the 22 along this longer path. So from here, if you keep going, there's only one way to get to Z, and that's along this 10 path over here. And that's obviously going to be the shortest solution. If you really want to make sure you can go in and add up all the numbers, 5 plus 2 plus 6 plus 5 plus 10, that's going to be 28. If you were to try the other ones, you'd have 5, 10, 17, we already kind of did that. You would all find that any of the other paths are going to be longer than 28. Also, if you wanted to bypass that checking process entirely, you could have just looked at the answer choices, which are 28, 29, 30, 31, and 32, and you could have seen that, wow, 28 is the smallest one. It's not possible that there's going to be a smaller value, because there isn't a smaller choice. That's another way you could have just come up with your answer right there. But either way, 28, choice A, is the shortest possible distance in kilometers you could go from A to Z through A, X, M, Y, C, and Z. That's the only path that yields such a short distance. So basically all we had to do there is just look at the numbers, see that we had a huge 25, we had a huge 17 and a 14. Those are obviously not going to result in the shortest paths. From there, all we had to do is look at the 5, look at the 2, and notice that, wow, those numbers are really small. Those are the smallest ones of this entire diagram, so obviously that's gotta be the way to go. And sure enough, that's the shortest path from A to Z. That was an explanation for the 2024 AMC 8 Problem 14.